All right, algebra kids, good morning. This is Mr. Kim. It's morning for you. Not feeling well, so I can't be here today. Sorry. Plan on being here tomorrow. In any case, we're going to get started at this point. You should have received your handout from the teacher. Um, it's not a handout that's actually part of the lesson. I created it, again, just to make things go by a little quicker. But in any case, we're going to get started. The whiteboard says that, or your agenda says that we've got problems 22 to 23. You're going to learn kind of a little bit more today than you did the other day. We're going to take what we know about residuals. We're also going to analyze a little bit more, and we're going to take calculations. Sorry, I can't really speak right now. I'm not feeling well. We're going to take our calculations, and that's not going to change, but what we are going to do is add more on top of the residuals. I got lost in my thoughts for a second. Sorry. All right, so let's just get into the lesson. In any case, you didn't have any homework, so we're going to get right into it. Teacher, please pause the video if you haven't passed out the handouts yet. All right, here we go. Today you're going to think about everything you know so far about statistical analyses, and you're going to write a report with all these elements. By writing a report later, this will turn into a big paragraph. Right now, it's just several sentences. Then you will learn a way you can report a range of values for your predictions. So here's the problem. In 1997, an anthropologist discovered an early humanoid in Europe. As a part of the analysis of the specimen, the anthropologist needed to determine the approximate height of the individual. The skeletal remains were highly limited, with only an ulna bone, forearm is the name, actual name that we know of, being complete. In other words, all the other bones that were found, not usable, except for the forearm. Your forearm, by the way, starts from your wrist all the way down to your elbow. The bone measured 26.4 centimeters in length. 26.4 centimeters is not that big. Be mature here a little bit, but if you take the center of your hand all the way up to about the end of your longest finger, your middle finger, that's about 10 centimeters for the average kid. Now, if you're taller, it might just be the middle finger. I know I keep saying middle finger, but I'm just trying to, anyway, you get my point. So that's about 10 centimeters. So 26.4, kind of map it out a little bit. That's how big this forearm is. Your task, you're going to consider how you can determine how tall the humanoid was. In other words, we don't know the actual height of this person, right? This humanoid. All we have is a bone. So let's take some data, let's make a scatter plot, and let's try to make some predictions. Discuss the questions below with your team. Be ready to share your responses. So let's just go down and scroll down here. Once your class has decided what elements your report should contain, collect and analyze your data with your team. Write a few sentences to the anthropologist with your findings. So first we need to find a scatter plot, then we need to find a line of best fit. Then we need to use our line of best fit to predict how tall this person is with a 26.4 centimeter forearm bone. And then we need to report on the association, interpret the slope, interpret the y-intercept, make sense of the y-intercept. That sounds like a lot. I will guide you through that. But here we go. So on your handout, you should see something like this, right? Let's go ahead and graph your data if you haven't already. I'm just going to do it as fast as I can. So we've got 23,143 about there, and then we've got 26,160, about right there, 27,173, we've got 24,175. We've got 28,165. We've got 26,154. We've got 29,185. And then we've got 21,147. There we go. Okay, so that's our rough sketch. I think I'm good. We're going to draw a line of best fit, not just yet though, because Some of you might notice that the y-axis and the x-axis is truncated. That's generally not a good thing to do, but I'll show you why I did that in just a second. But in any case, let's zoom out. So this is going to go away. 3, 2, 1. And what I'm going to do is show you my Desmos graph. And let me change the view here. Let's go to projector mode. So this is pretty much what you have on your what do you call it, your handout there in front of you. This is the reason why we zoomed in, and the reason I truncated it is because this is what you would see. It's hard to draw a line of best fit through this, so we kind of zoomed in. And again, the point of today is not drawing a line of best fit, but it's learning what upper and lower bounds are. So let me zoom in here real quick and show you what the line, actually let me give you the line of best fit right now. It's going to be y equals 3.9x plus 63.3. Okay, so there it is. So you can kind of tell what it looks like going through. That's the y-intercept down over here at 63.3. And now I'm going to change my window so that I can kind of see it a little better. I'm going to change it to pretty much what we have on our handout. So we're going to go from 18 to about 32. And I believe the y-axis is like 140 to about 200. 120? Let me check. Yeah, there we go. That's about what we've got. Okay. So notice now, based on what we have here, it looks like the y-intercept is, going through anywhere between 120 to 130. So that's what I mean by the truncating the graph. It's not a good strategy. But again, for the purpose of today's classwork, we don't really care because I gave you the equation anyway. Right next, so next to your line of best fit, not on the graph, but on the side, go ahead and write the line of best fit. So y equals 3.9x plus 63.3. Don't write it on the line because we're going to do some work here in this region. So again, just write it next to your line, either on the left or the right side. All right, here we go. We're going to move on. So what we need to do now is predict the value of this, sorry, not the value, the height of this person. So we need to substitute 26.4, which is the x value. So 26.4 into x here times 3.9 plus 63.3. Turns out that the height of this person is 166.26. So I'm just going to write down 166.26. So they're about right there. Okay, now don't draw this line. It's just because we're in a graphing calculator, it draws a line like that. If I wanted to be even more accurate, I should have just made a coordinate. Let me change that. 26.4 centimeters, comma 166.6. So there it is. Please go ahead and put a dot there and label that humanoid. Right? We don't know who it is. Give her or him a name if you want, but humanoid is fine. So that's the predicted height of this person, 166.26 centimeters. There's about 2.4 centimeters in an inch, so if I divide that real quick, a person is about 69 inches tall, 72 inches is 6 feet-ish, so this person is somewhere between 5 and 6 feet. All right? And so the reason why I say 5 and 6 feet is because we don't actually know how tall this person is, but that's a rough estimate. So it's about the average person, right? Somewhere between 5 and 6 feet tall, which is good. All right. Anyway, we found this. Make sure you write it down. And now we have to write a report. So in the report, here's what you need to do. And we're going to pause the video after I explain all this. You're going to explain the association of this model. This equation is called a model. All right. You're going to explain the association. We've got direction, positive or negative. We've got form, linear or nonlinear. We've got strength, moderate, weak, strong. And we've got outliers. It's up to you and your team to determine the association. You're probably going to have the most conversation around strength. Sorry about that phone call. In any case, where was I? Yeah, form. Oh, so association. And then you're going to say what the predicted height is of the person who has a forearm bone of 26.4 centimeters. You're going to describe your slope and interpret it. So for every increase in forearm, for every 1 I can't talk. For every 1 centimeter increase in forearm length, the height increases by what? And then lastly, what the y-intercept means, and if that makes any sense. And I'm letting you guys discuss that. Okay. So here we go. Teacher, get ready to pause, and kids get ready to discuss and write this down. Teacher, when the kids are done, maybe about 3 to 5 minutes, start playing the video again, please. 3, 2, 1, go. Alright, so hopefully there was good discussion and you guys got it all down. This is going to go away for now, so let's change screens here. Real quick, what I'd like you to do is draw the full graph of what I just showed you, kind of the, let me just show you. Let's draw the dots here, just like put 0, 30, yeah, 30, and then place a 200 up here, and then draw some dots kind of like this, mimicking what I showed you right on Desmos earlier. And what I want you to do is I want you to then put a kind of a box around here and then point down towards this to show that the work that I know it disappeared, right, the work I did here, but that this actually was represented here when we zoomed in. Alright? Okay. Here we go in 3 and 2 and 1. This is going to go away. Alright, let's get back to the actual lesson. It says 62 we're done. We wrote a report. You guys described stuff, all that jazz. 623. Because the height you found for the humanoid is a prediction meaning it wasn't accurate. We have no way of knowing how accurate this is. It was just based off of a scatter plot. The actual height of the early humanoid was probably a little shorter or a little taller. Remember I said like about 5 to 6 feet. Maybe closer to 6, maybe closer to 5, we don't know. In this problem you will now investigate how you can report a range of values. Let's go back to what range is. Range, if you remember, back in the day you guys had to do this thing called like a box and whisker plot. Right? So then this was your max value and this was your min value. The range was the amount of the difference between these two. So if your minimum was 10 and your max was, let's say, 90, the range equaled 80. That's what we're talking about right now. But we're talking about more data, not just a box and whisker plot. So this is going to go away. Actually, let's just do this. All right. So it says, look at the data you collected in your model line. Okay, so that's the line of best fit. Identify the point that is farthest from the line you drew. Find the residual for this point. Don't do that yet because I'm going to read B. In a different color, draw a dashed line that goes through this maximum residual point and is parallel to the line of your model. So it kind of mimics this, right? If this is the line of best fit, then after we find the largest residual, draw a parallel line through that residual point above or below, depending on the problem, above or below, depending on the problem of the line. And then, now draw another dashed line that is on the other side of your model and is the same distance away as the first dashed line. So if our residual that's the furthest is above, then we're going to draw one above, one below. If our residual that's the largest is below, then we draw below, then above. Either way, it's on the top and the bottom. It just depends on where the largest residual is. When they say largest residual, they're saying the absolute value distance. So not so much negative versus positive, but the actual physical distance. It could be plus 10 up, it could be minus 10 down, but that's also a distance of both sides, 10 and 10. So here we go. Go back to the graph. All right. This point I'm going to take away because it might be distracting. So that's gone. So if you kind of look at the data, you can clearly see that between this point, this point, this point, this point, this has the furthest residual. So what we're going to do is calculate the residual. We know what the coordinate is, so let's label that. This is 24,175. Go ahead and label that on your graph. Okay, and then we're going to draw a line of best, not a line of best fit. We're going to draw here. Let me do it in red. A vertical line from here to here and place a dot there. We're going to find the distance of this residual. Please remember how we did that. We have to find the distance on the line versus the distance on from the point. So we have to plug in 24 into our line of best fit, to do that. So do that now. 3.9 times 24 plus 63.3. And this coordinate is 156.9. So I'm just going to label that. This is 24, 156.9. Okay, so you should do the same. So remember, the residual was pretty much the actual minus predicted, right? So let's go. I'm going to write that at the top. Residual equals actual minus predicted. So make sure you do that, okay? So actual was the one that was actually graphed, so 175 minus 156.9. So 175 minus 156.9 is roughly 18.1. So this is a positive 18.1. All right, so that's the residual. Let's put labels on this because it's not just 18.1, it's 18.1 centimeters. All right, and then they suggested drawing a line parallel through that point. Now we're going to do that, but I'm actually going to do the other part first. Let's go below 18.1 centimeters. So what I want to do is, instead of adding 18.1 to 156.9, because I went vertically to get 175, let's subtract 18.1 from 156.9 to find the actual coordinate that is negative 18.1 below this line. Okay, so 156.9 minus 18.1 comes out to be 138.8. So I'm going to try to find 138, which is roughly about, actually, it's roughly about over here, right, 138. And I'm going to put a dot right at around 138.8 or 139, okay, right there. I'm going to draw that line and mark it negative 18.1, and we're going to put units, centimeters. And then we're going to draw a line of best fit through both the top and the bottom. Oh, I should label that coordinate. 24, 138.8. All right, so now we have created, what we have is the boundary for the upper, boundary for the lower. So your job is then to create a line of best fit. Here's how you do it. I'm going to use the technology just because I can. Oops. Actually, I can't. Never mind. I have to actually physically draw. Limitations of technology. We're going to draw a dashed line. This is not an inequality. It's just representing the fact that these lines don't really exist. We are making them up. So something like that. I know that's horrible, but deal with it. And then like that. Okay, so this is the upper bound, that's the lower bound. In other words, we have a maximum point, a minimum point. Now we can find our range, but let's also find the lines of these equations here. So this is going to be y equals, now since we said parallel to this line, that's going to be 3.9x. Now what's the y-intercept going to be? Well, think about it. We went from here, which was 63.3, and we went up 18.1 units. So what do you think we should do with 18.1 and 63.3? If you said add, perfect. So we're going to take 63.3 plus 18.1, and that's going to be an 81.4. Right? So that's the y-intercept now. Same thing, if we have 156.9 and we go minus 18.1, then we're going to take our y-intercept, go minus down 18.1. So 63.3 minus 18.1, and we now have y equals 3.9x plus 45.2. And so there are your two new boundary points, your boundary lines, your upper bound and your lower bound. Okay? So what we're going to do now is calculate our range, the distance between the two. Now, if you have figured it out, the range will pretty much act like the residual doubled, but let's just verify. So let's do 175 minus 138.8. 175 minus 138.8. We're not going to use a calculator because I want you to see this. So 36.2, right? Let's take 18.1 times 2 in your head. That's 36.2. So pretty much our range is 36.2 centimeters. So put label centimeters. In other words, from Lucy, I don't know why I said Lucy. Let's just call her Lucy. Who cares? I don't know, because it's a humanoid, right? So from Lucy's height, predicted height of 156.9 centimeters, we have an error of plus or minus 18.1. So let's write that down. So our error, write this down somewhere, preferably probably not inside your graph. Our error is plus or minus 18.1 centimeters. You wanna write that down. In other words, we can be off by positive 18.1 centimeters or negative 18.1 centimeters, to the tune of she's either taller or shorter by this amount. So our range then, or how much wiggle room we have, is 36.2 centimeters. All right, so that's pretty much what this is saying. Now, if you want to really think about this carefully, 36 centimeters is probably, I want to say, right, if we remember we said 20, what am I saying? Oh, the forearm was 26.4 or 24.6? I forget. Anyway, 26.4. The forearm was 26.4 centimeters long. That's a pretty long forearm. That's not the tiniest thing, but it's a good size. And now we're talking a 36.2 centimeter range potential error, which means that this person, Lucy or whoever, if we predict their height, right, they could actually be 18.1 inches taller or centimeters or 18.1 centimeters shorter. In other words, we might be off anywhere between 3 to 8 inches, okay, depending on where the person is, right? So you want to discuss with your group real quick, or you want to have this discussion as I wrap up here. Okay, this is all going to go away. 3, 2, 1. Let's answer this final question here. Okay, we kind of did this using the upper and lower bounds, create a range of values. We did that. With your team, discuss the bounds of the data. What was when it says create a range of values, they actually want the actual values. I'm sorry. So when they say range of values, they're asking for the highest and the lowest, the minimum and the maximum. So answer that way. But the actual range was 36.2. With your team, discuss the bounds of the data. Was your model useful for predicting the height of the humanoid? Right? So like I said, we're off anywhere between 3 to 8 inches. Now think about 3 to 8 inches. I myself, on a good day, I'm 5'8" if I'm wearing the right shoes. If I'm not wearing shoes, I'm like 5'7.5". Right? So on a good day, if I'm 5'8", if I'm off, if you can add 3 inches or 8 inches to my height, I'm hitting about 6 feet almost, and 6 feet is pretty tall. Some of you might be 6 feet, not everybody, but you all know who some of the students are who are tall. If you stand us side by side next to each other, just want to answer the question: is that accurate or not? I'm just asking, right? Your job is to answer. Likewise, imagine if the person was 3 to 8 inches shorter than me, right? So I'm 5'8", right? Because I'm saying I am. Minus 3 inches is 5'5". Minus 8 inches is 5 feet, all right? So in other words, with your team, discuss the bounds of the data. Was your model useful for predicting the height of the humanoid, right? And you will have to support this. So use logic, use reasoning, use the numbers, use the facts, right? And make a statement and support your conclusion. That's it for me. Good luck. When you're done, get your classwork stamped and get your homework started. Have a good day. I will see you tomorrow. Bye-bye.